All right, good morning, class. We're going to go over 9.2. Well, actually, it'll be a combination, but we're going to go over 9.2. We're going to use sine and cosine now to solve, to find side lengths as well as angle measurement. So here we go. Here's the easiest way to remember sine, cosine, tangent, SOHCAHTOA. SOHCAHTOA says for sine, we're going to do the opposite side over the hypotenuse. For cosine, we're going to do adjacent over hypotenuse, and tangent, which we've already learned, is opposite over adjacent. Hopefully I said that. So opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. So we did tangent. I'm going to skip through this one because we've gone through it. Sine is opposite over hypotenuse, so opposite leg over hypotenuse, and cosine is adjacent over the hypotenuse. So if we look at this, we want to find sine of angle A. We go angle A is opposite over hypotenuse, so we go y over z. Then we go sine of B, so now we go with sine of angle B is equal to opposite x over z. Then we want to go cosine of angle B. Cosine is adjacent y over hypotenuse z. Cosine of angle A is adjacent x over the hypotenuse z. And then we go tangent B, which we did yesterday, would be opposite x over adjacent y. Tangent A is opposite over x, and then from B would be x over y. So we can go through the same idea here. We want to find the sine of angle A. So we start out would be opposite 12 over the hypotenuse, which is 13. Sine of angle B would be opposite 5 over hypotenuse 13. Cosine B, so we go adjacent over the hypotenuse, so 12 over 13. Then we go of cosine B, adjacent 5 over the hypotenuse. And then tangent A. Tangent from angle A, opposite over adjacent, 12 over 5. And then from B, we go opposite 5 over 12. So we can go through these, we'll skip through that. So now we're going to actually find the length of a side using sine, cosine, or tangent. So we have to look at our angle. So from angle 57, this side 10 is what, and this side x is what. So from this side, this would be, well, we know x is the hypotenuse, so it's opposite the right angle. So if we're using hypotenuse, we'll either use sine or cosine. Angle, side 10 is opposite. So opposite over hypotenuse would be sine. So we go sine of 56 equals opposite over the hypotenuse. Then to get rid of, we got to get x out of the denominator, so we multiply each side by x. So we times it by x. Sine of 56 is about 0.83, and then we divide. So we get about 12.06. We go to this one, we want to again look at it. We know that this is the hypotenuse, so I'm either using sine or cosine. This side from x is adjacent to angle 35, so that adjacent and hypotenuse would be cosine. So we go cosine of 35 is equal to x over 20. So then we come from there, looking at it, we wanted to solve for x, we get rid of 20, so we multiply each side by 20. So 0.82, which is, again, if you plug this into your calculator or back of the book, then you multiply it by 20, so it would be 16.38. Again, this is the length of this side here. One more, we look at it. So again, we're looking at this is angle x, would be our hypotenuse, so it's either sine or cosine, or side x. This side 12 is next to our angle, so next to or adjacent to our angle, and hypotenuse would be cosine. So cosine of 43 degrees is equal to 12 over x. You can estimate out what this is, or we're going to move x over. So move x over and then divide. So 12 is equal to cosine 43 degrees. Plug that into your calculator and you get about 16.4. So we want to find the angle measurement. So if we think about tangent, what we did yesterday, remember we had the inverse, so it's tangent, then tangent inverse. Same thing here. We start with our angle. If we look at it, this is the hypotenuse. So it's opposite over hypotenuse, which would be sine. So we go sine of angle x equals 6.5 over 10. Now to remember, to get rid of sine, we got to do the sine inverse. So it cancels off that side, and we have x is equal to the sine inverse, 6.5 over 10. Plug that into your calculator, and you get about 40.54 degrees. Which again is good. This should be the smallest angle. This one puts this one about 50 degrees. Set it up. We look at it again. This side is adjacent to this angle, and this side is the hypotenuse. So adjacent and hypotenuse would be cosine. So I say that cosine of x is equal to adjacent 10 over the hypotenuse 27. We go ahead and do, to get rid of, well, I did it out of order. To get rid of cosine inverse, we have to, or to get rid of cosine, we do the inverse. All right, so then we go x is equal to the cosine inverse of 10 over 27, and you plug that in at 68.26. So that's what we're looking at doing. So those are our ratios. Again, I can't encourage you guys enough. I'd write SOHCAHTOA on the top of your paper. If we go back to this first slide, I'd write it as you see it, because it'll just help you right here. I'd write this down, SOHCAHTOA. You could write it this way, or you could write it as the ratio, one over the other. It'll allow you just to remember how to solve it and to go forward. What are we going to use, sine, cosine, or tangent?